We're going to start with a farmer application here. So this is a very practical problem. A farmer owns a 300-acre farm and he wants to plant at most 3 crops: wheat, corn, and cotton. The seed for crops wheat, corn, and cotton costs $30, $40, and $50 per acre respectively. And a maximum of $6,400 can be spent on seed. Now, crops wheat, corn, and cotton require 1, 1, and 2 work days per acre respectively. So now what that means is that 1 acre of wheat requires 1 acre of work day, 1 acre of corn requires 1 acre of work day, and 1 acre of cotton requires 2 acres of work day, and so forth. And there are a maximum of 200 work days available. If the farmer can make a profit of $200 per acre on wheat, $250 per acre on corn, and $100 per acre on cotton, how many acres of each crop should be planted to maximize profit? So the farmer must decide on the number of acres of each crop that should be planted. So we'll just let our variables x1 be the number of acres of wheat planted, x2 the number of acres of corn planted, and x3 be the number of acres of cotton planted. Now the farmer is constrained by the number of acres available for planting, the money available for seed, and the available work days. So these lead to the number of acres available. Remember, the farmer only has 300 acres, so we know that if you add the number of acres for each crop, it has to add up to a number that's less than or equal to the number of acres available, which is 300. And now the farmer only has $6,400 available for seed. And if you look up here, remember it costs $30 per acre for wheat, $40 per acre for corn, and $50 per acre for cotton. So 30x1 plus 40x2 plus 50x3 is your total seed cost, and that has to be less than or equal to 6,400. And then also there's only 200 work days available. And so the number of work days for wheat would just be the number of acres, x1. The number of work day required for corn, same thing, the number of acres, which would be just x2. And the number of required work days for cotton would be twice the number of acres of cotton, so it'd be 2x3. So that would give you x1 plus x2 plus 2x3 is less than or equal to 200. So now, if I asked you to set this problem up, then basically all you would give me would be the linear programming model right here, where you state what you got to state whether you're maximizing or minimizing. In this case, we're maximizing the profit. Your profit function, if you go back and read the problem, it tells you right out that the profit for each acre of wheat was $200, the profit for acre of corn was $250, and the profit per acre of cotton was $100. And then we throw in our 3 problem constraints, these 3 problem constraints. And then don't forget to write your non-negative constraints, because you got to have those as well. Because you know you can't plant a negative number of acres of any crop. Now, to solve this, add your slack variable to each one of these. Well, first of all, make sure it's a standard maximization problem, and it is, because you're maximizing and all the constraints are less than or equal to non-negative numbers. But then add your slack variables to each one of these, and you'll get x1 plus x2 plus x3 plus s1 equals 300, 30x1 plus 40x2 plus 50x3 plus s2 equals 6,400, x1 plus x2 plus 2x3 plus s3 equals 200, and then move these numbers across the equal sign, and you'll get minus 200, minus 250, minus 100 for the coefficients, and then plus p equals 0. And you know that none of these variables can be negative, so they all have to be greater than or equal to 0. Okay, so now what we're going to do is we're going to put this in a tableau. So you're going to have a column for x1, x2, x3, your 3 slack variables, and p. And then you know how to do this. Just put your coefficients in. 1x1 plus 1x2 plus 1x3 plus 1s1 has to equal 300. The second equation, 30x1 plus 40x2 plus 50x3 plus s2 has to equal 6,400. The third equation, x1 plus x2 plus 2x3 plus s3 has to equal 200. And your last equation, negative 200x1 minus 250x2 minus 100x3 plus p must equal 0. And you know you're starting out with S1 as a basic variable identified with row 1. S2 is a basic variable identified with row 2. S3 is a basic variable identified with row 3. And P is a basic variable identified with row 4. Now, since we have negatives on the bottom row, we know we have to go through the pivoting process. And since negative 250 is the most negative indicator, that's got to be the pivot column. So then we divide these three numbers into their constants. Well, 300 divided by 1 is 300. 6400 divided by 40 is 160. And 200 divided by 1 is 200. So it looks like the 160 is the pivot row, identifies the pivot row. And so that means that the pivot row and the pivot column intersect at this 40. Now again here, I'm just going to tell you what your row operations that you're going to need. You're going to have to do, first of all, before you try to eliminate things, you're going to have to multiply this row by 1 over 40. So do that first. Multiply row 2 by 1 over 40. And then that'll make this a 1. And then after you do that, multiply the new row by negative 1 and add it to row 1. And that will cancel the 1 that's in row 1. And then also multiply this new row by negative 1 and add it to row 3. And that will cancel the 1 that's in row 3. And then multiply the new row by 250 and add it to row 4. And that will cancel the negative 250 that's in row 4. And so then you're going to get this tableau right here. Now notice here, it looks like I only have one negative indicator again. So that has to be my pivot column, the negative 25 halves. And now I have to divide 1/4 into 140, which gives me 560. Divide 160 by 3/4. So in other words, divide 3/4 into 160. And I got a little over the 213. I just used a calculator. And then 40 divided by 1/4 would be 160. So looking at those three quotients, 160 is the smallest one. So that means that this is my pivot row. And so what I will do here is I will see where the pivot row and the pivot column intersect. And that's going to give me the pivot element. Now let me correct something here. I see a little error here. So I just corrected these two guys right here. The X2 that entered in that last example, it actually entered in row 2 because the one's right there. So that should say X2. And then the S3 never went anywhere. So the S3 is still right there for now. Okay. So anyway, I just wanted to make sure that was corrected. All right. Now I need to make this 1/4 be a 1. So I'm going to multiply row 3 by 4 so it'll become a 1. Now after we do that, after we multiply that and get the new row, then we're going to multiply this row by negative 1/4 and add it to this row. And that would be this row operation here. And then we're going to multiply this row by negative 3/4 and add it to this row. And that would be this row operation here. And then we're going to multiply this row by 25 halves and add it to this row. And then that would be this row operation here. And then when you do those row operations, you'll get this tableau. And now since there's no negatives on the bottom row, you have your final tableau. And so now notice here in this tableau that X1 is a basic variable and it's identified right here. So X1 must be 160. X2 is a basic variable and it's identified in row 2. So X2 must be 40. X3 never entered, so X3 stayed non-basic, so it's going to be 0. Now if you wanted S1, you could get it from row 1, which is 100. And S2 and S3, they never entered. So, well, they exited. Actually, they both exited. So they became non-basic, so they're 0. And then P actually equals 42,000. So, in summary, you need to plant 160 acres of wheat, 40 acres of corn and no acres of cotton, and that's going to give you $42,000. Now, what's interesting though is if you go back and look at your constraints, 160, 40, and 0, if you go back and look at your constraints, you'll notice that you're only going to use 200 acres of land, because 160 plus 40 plus 0 is 200. But that's okay, you just had to make sure you were under 300. Now if you plug the numbers into here, it'll actually come out to $6,400, so you'll actually use all of your seed money. And if you plug the numbers in here, it'll come out to 200, and so you'll use all of your work days. But you won't use all of the land that's available. So I just thought that was interesting. So that's how you solve that. So I'm going to wrap this up with one more video, and on the last video I'm just going to show you how to set up a couple of word problems.